Welcome back to Arxflix. Today, we're diving into the fascinating paper, Classifier-Free Diffusion Guidance. This research explores how to perform guidance in diffusion models without the need for an additional image classifier. This figure shows the effect of guidance on a mixture of three Gaussians, representing data conditioned on different classes. The leftmost plot is the non-guided marginal density. As we move to the right, the densities evolve with increasing guidance strength. Classifier guidance is a popular method that improves sample quality in diffusion models by utilizing an extra trained classifier. This method combines the score estimate of a diffusion model with the gradient of an image classifier's log probability. However, this approach has some setbacks. It complicates the training pipeline and is reliant on an accurately trained classifier. Furthermore, the classifier needs to be trained on noisy data, making it difficult to reuse pre-trained classifiers. This also raises questions about whether the improvement comes from adversarial attacks on the classifier. To bypass these complications, the authors propose classifier-free guidance. Instead of relying on a classifier, they jointly train a conditional and an unconditional diffusion model. The approach leverages the score estimates from both models to achieve a trade-off between sample quality and diversity, similar to classifier guidance. Here we see samples from the proposed model. The left image shows non-guided samples, while the right image shows samples generated using classifier-free guidance with a guidance strength of 3. Notice the increase in sample fidelity with the strong guidance. The diffusion models used in this research operate in continuous time, as described by Song et al. They leverage a forward process that gradually adds noise to data, turning it into Gaussian noise. During training, an objective function similar to denoising score matching is used. Traditional methods like GANs and flow-based models implement truncation to balance sample quality and diversity. Unfortunately, straightforward attempts at implementing this in diffusion models are ineffective and often result in blurry samples. Terwell and Nicol introduced classifier guidance, where the diffusion model's score is amplified using a classifier's gradient to improve perceptual quality. The score modification looks like this. However, this method remains dependent on noisy classifiers. Classifier-free guidance, by contrast, requires no classifier. It simply combines the score estimates of a conditional and an unconditional diffusion model. This approach leverages purely generative models, avoiding any classifier-based adversarial behavior. The authors validate their method on ImageNet at 64 by 64 and 128 by 128 resolutions. They demonstrate that classifier-free guidance produces a competitive trade-off between inception score, IS, and freshet inception distance, FID. This table summarizes performance metrics. The results confirm that classifier-free guidance achieves high sample quality comparable to previous state-of-the-art methods, sometimes even outperforming them. One notable advantage of classifier-free guidance is its simplicity. It requires only minor changes in the training and sampling processes. On the downside, sampling speed can be a concern since the method requires evaluations for both conditional and unconditional scores. Classifier-free guidance effectively enhances sample quality in diffusion models without the need for an additional classifier. This opens up new opportunities for harnessing the power of pure generative models in generative AI research. That's it for today's video. If you found this summary helpful, don't forget to like, subscribe, and hit the bell icon for more research summaries. Thanks for watching Arxflix, and see you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.